Now in this section we're going to do the substitution method. Now what does the substitution method entail? Now sometimes in a given first order differential equation, alright, it may not fall into either of the categories we discussed earlier in section 1, 2 and 3. So in this case we may use substitution to transform the given dE to one of this form. Yeah, so either one of these, right? dy dx equals fx or dy dx equals f of y. Then we need to integrate directly or use variable separable. So direct integration we already touched on it, and then variable separable also we've already talked about it. Right. So let's look at the next example, in example 7, which actually uses substitution. Now in the syllabus, if you need to use the substitution method, the substitution will be provided for you, so you don't have to come up with your own substitution. Okay, similar to integration techniques, the substitution will actually be given to you. Alright, so example 7. Now in example 7, the substitution that they ask you to actually adopt is y equals to vx, and then the dE that you need to solve is this. Right, so the idea of substitution is to convert one of the variables into another, alright, so that your dE will actually become much simpler for you to solve. Okay, so let's start. Right. So in this case you are given that y is equals to vx. Now in your question, the dE that you see here is dy dx. The derivative that you see here is dy dx. So you are going to get rid of the variable y and then change it to the variable x. Variable v. Okay. So in order for you to do that, alright, you need to, from this stage, okay, alright, get what is the derivative, the first derivative. Okay, so from here, differentiating with respect to x, you will have dy dx. Alright, okay, on the right you need to apply your product rule. So v fixed, differentiate x, you get 1, then plus x you fix, you differentiate v. Now bearing in mind that v is also a variable, alright, so if you differentiate v with respect to x, you will have dv dx. Okay, alright, so putting this newly formed dy dx into this equation, alright, you would have already eliminated, removed the dy dx from the original equation. So let's just do that. Okay, so on the left you have x times dy dx, but dy dx is now v plus x dv dx, right? And then on the right you will have x power 4 plus 2x cubed plus y. Now this part here is y, right? But because we want to convert our variable y to v, so now using this relationship, alright, what is therefore y? Vx. So we got vx over this side. Okay, so are we there? Not there yet. Alright, so if we were to simplify this, okay, you will have xv plus x squared dv dx, right? And on this side you will have x power 4 plus 2x cubed plus vx. Okay, simplify further, you will actually get dv dx is equals to x squared plus 2x, because you can already see that this xv and this xv can be cancelled off, and then you can divide throughout by x squared to reach to this stage. Okay, now comparing this so-called converted dE with the original. Alright, now I know that you would already have realized that this newly formed dE is easier to integrate. In fact, you can actually integrate this directly with respect to x. Okay, so integrating the dE directly with respect to x, you actually have this answer, right? So if I were to actually write down one more step, okay, it goes like this, right? So integrate dv dx with respect to x, alright, and then on the right side plus 2x bracket dx. Okay, so on the left side, when you integrate dv dx with respect to x, you actually have v, and then on the left side you just integrate each term to get what you see here. Alright, and again, don't forget that c is the arbitrary constant. Now after doing so, alright, if you were to look at the original dE, the original dE is equation that tie in the variable x with the variable y, but what you have at this stage is still v with x, right? So you need to convert back your v, to the original variable y. Okay, so using the substitution that the question actually provided you with, alright, you change your v to y. So the final answer is now this. So this is your general solution.